Hi guys. Welcome to another video of Learning Hub. Hope you are all well. First thing first. If you are new to our channel, then you know what you have to do. Yes, subscribe to our channel Learning Hub and smash the like button. Also press the bell icon to get instant updates of new videos. Okay, so let's start today with Roblox Studio Tutorial Understanding CFrames. A CFrame, short for coordinate frame, is a data type used to rotate and position 3D objects. As either an object property or a standalone unit, a CFrame contains global X, Y, and Z coordinates, as well as rotation data for each axis. In addition, CFrames contain helpful functions for working with objects in the 3D space. Some examples of CFrame applications in a game might be finding a far-off target point for a projectile, like the position of an enemy targeted by a player's laser blaster. Moving the camera so that it focuses on specific NPCs as a player interacts with them. Placing a status indicator directly above a player's head to show if they are paralyzed, boosted, poisoned, etc. CFrame basics. Positioning a CFrame. An empty CFrame can be created with CFrame.new at a default position of 0, 0, 0 in the game world. To position a CFrame at a specific point, however, you should provide X, Y, and Z parameters to CFrame.new. In the example, the red block object is repositioned at -2, 2, 4 by overwriting its CFrame property with the values stored in new CFrame. Local red block equals game, workspace.redblock. Create new CFrame. Local new CFrame equals CFrame.new -2, 2, 4. Overwrite red block's current CFrame with new CFrame. Redblock.CFrame equals new CFrame. Alternatively, you can provide a new vector3 position to CFrame.new and achieve the same result. Local red block equals game, workspace.redblock. Create new CFrame. Local new vector3 equals vector3.new -2, 2, 4. Local new CFrame equals CFrame.new, new vector3. Overwrite red block's current CFrame with new CFrame. Redblock.CFrame equals new CFrame. Rotating a CFrame. To create a rotated CFrame, use the CFrame angles constructor, providing a rotation angle in radians for the desired axis. Local red block equals game, workspace.redblock. Create new rotated CFrame. Local new CFrame equals CFrame, angles 0, math.rad 45, 0. Overwrite red block's current CFrame with new CFrame. Redblock.CFrame equals new CFrame. As noted, parameters to CFrame angles must be specified in radians, not degrees. If you prefer degrees, simply use the math.rad converter as shown in this example. Facing toward a point. One of the most powerful uses of CFrame.new is the ability to point the front surface of a CFrame at a specific point in the world. Consider the example which places the red block part at 0, 3, 0 and then points its front surface, marked by the white circle, at the blue cube part. Local red block equals game, workspace.redblock. Local blue cube equals game, workspace.bluecube. Create a vector3 for both the start position and target position. Local start position equals vector3.new 0, 3, 0. Local target position equals bluecube position. Put the red block at start position and point its front surface at target position. Redblock.CFrame equals CFrame.new, start position, target position. Offsetting a CFrame. In some cases, you'll need to offset an object by a specific number of studs from its current position. This can be done by simply adding or subtracting a vector3 to a from a new CFrame created at the object's position. Local red block equals game, workspace.redblock. Redblock.CFrame equals CFrame.new, redblock, position, plus vector3.new, 0, 1.25, 0. To get a properly formatted vector-3 position of an object to use with CFrame.new, as seen here, its position property, red block, position, is a convenient shortcut. The same technique can be used to offset an object from the position of another object. This time, a vector-3 is added to a new CFrame created at the blue cube's position instead of the block's position. Local red block equals game, workspace.redblock. Local blue cube equals game, workspace.bluecube. Redblock.CFrame equals CFrame.new, blue cube, position, plus vector3.new, 0, 2, 0. Dynamic CFrame orientation. By themselves, the CFrame.new and CFrame angles constructors are powerful, but they are also very strict. They simply position or rotate an object at a specific orientation within the world. This is useful in some cases, but what if you can't rely on a fixed world position and rotation angle? For instance, placing a floating treasure directly in front of a player, who may be standing anywhere in the world, facing any direction. Making a magical genie appear directly above a player's right shoulder. In these cases, CFrame functions are far more powerful than the strict constructors. Relative position. The CFrame, to world space, function transforms an object's CFrame, respecting its own local orientation, to a new world orientation. This makes it ideal for offsetting a part relative to itself or another object, regardless of how it's currently positioned or rotated. In the code, notice that the red block gets offset 2 studs relative to the y-axis of the blue cube, the green arrow pointing through it, and not relative to the global y-axis pointing straight up. Local red block equals game, workspace.redblock. Local blue cube equals game, workspace.bluecube. Local offset CFrame equals CFrame.new, 0, 2, 0. Redblock.CFrame equals bluecube.CFrame, to world space, offset CFrame. Relative rotation. CFrame, to world space, is also useful for rotating an object relative to itself, for instance rotating it 70 degrees counterclockwise on its current y-axis, and 20 degrees clockwise on its current z-axis. Local red block equals game, workspace.redblock. Local rotated CFrame equals CFrame, angles 0, math.rad 70, math.rad 20. Redblock.CFrame equals redblock.CFrame, to world space, rotated CFrame. Facing a specific surface toward a point. As illustrated earlier, you can make an object look at another object by supplying a vector-3 point as the second parameter of CFrame.new. This can be limiting, however, since the operation is associated with the object's front face. Fortunately, you can use relative rotation to make any face of the object point toward a vector-3 point. Consider this example, which performs 2 consecutive CFrame operations. Point the front surface, marked by the white circle, at the target. Rotate the CFrame to make the top surface, marked by the black circle, point toward the target. Local red block equals game, workspace.redblock. Local blue cube equals game, workspace.bluecube. Create a vector-3 for the target position. Local target position equals blue cube, position. Point the red block's front surface at target position. Redblock.CFrame equals CFrame.new, red block, position, target position. Rotate red block CFrame relative to itself so that its top surface, not front, points toward the target. Local rotated CFrame equals CFrame, angles, math.rad, -90, 0, 0. Redblock.CFrame equals redblock.CFrame, to world space, rotated CFrame. Finding a point between points. Using a method known as linear interpolation, often referred to as LIRP, you can position a CFrame between 2 points. For instance, the following code positions the red block part directly between the green cube and cyan cube parts, using a value of 0.7 to place it 70% of the distance away from the green cube. Local red block equals game, workspace.redblock. Local green cube equals game, workspace.greencube. Local cyan cube equals game, workspace.cyancube. Redblock.CFrame equals greencube.CFrame, lerp, cyancube.CFrame, 0.7. These pointers should get you started on orienting objects in the game world via CFrame constructors and functions. Once you have a solid understanding of these concepts, consider exploring advanced CFrame manipulation in CFrame math operations. We will be sharing more video and Roblox tutorials, and then you will be able to make your own games on Roblox for fun and profit. Also share this video with your friends. Subscribe to channel and like the video. Till next time, stay safe and follow us for more upcoming tutorials.